In Final Exam Review 3, we're going to take a look at the most recent things we covered in chapters 8 and 9. In problem 1, we have that the average number of students in a high school class is said to be 25.4 with a standard deviation of 7.8. If 10 classes are randomly selected, what is the probability that they will have an average number of students between 24 and 26? So similar to what we did in chapter 7 with calculating z-scores, we're going to do the same thing here. So we need two z-scores. So z-score 1, where I'm going to use my smaller value, 24 minus 25.4 over, now typically we would do it over the standard deviation, but because we have a population that we're drawing from in our denominator, we have to do 7.8 divided by the square root of 10. We have to divide by that standard error because we're not talking about a population, we're talking about a sample. So once we do that in the calculator, we're going to get negative 0.57. We're going to do the same thing for our second z-score. We're going to do 26 minus 25.4 over 7.8 over square root 10, which is going to give us 0.24. Now we're going to use our z-score chart to find each of these z-scores and subtract them. So the z-score for 0.24 is going to be 0.5948 minus the z-score for negative 0.57, which is 0.2843, which is going to give us a probability of 0.3105. So about a 31% chance. In problem 2, we have the exact same scenario, but now we're upping our sample size to 41 classes. So the reason is so we can see how a larger sample size reduces the variability in our answer. So we're going to calculate our z-scores the exact same way. We're going to do 24 minus 25.4, but this time my denominator is going to be 7.8 divided by the square root of 41, which is going to give me negative 1.15. So we can see already how just increasing the sample size to 41 has significantly changed the z-score outcome. Our second z-score, we're going to do 26 minus 25.4 over 7.8 divided by the square root of 41, which is going to give us 0.49. Again, we can see an increase in our z-scores. So now using our chart, the z-score for 0.49 is going to give us 0.6879 minus the value for negative 1.15, which is 0.1251. So we can see how the 0.49 increased the first value, but the negative 1.15 decreased the second, which is going to give us an overall probability of 0.5628. So again, we can see that the probability changed significantly by over 20% just by increasing our sample size. Problem 3, we have that a researcher wishes to estimate the mean salary for a beginning zoologist. In an SRS of 41 beginning zoologists, it was found they had a mean salary of $31,782 with a standard deviation of $1,456. Compute and interpret the 90% confidence interval for the mean. So anytime we're talking about confidence interval for mean, that's a t-score. So we want to use our t-score formula, which is x bar plus or minus our t-score times the sample standard deviation divided by square root n. It's important for when you identify your t-score, you do your degrees of freedom. So you have to do the n minus 1. So our degrees of freedom, 41 minus 1 is 40. So if I go to the 90% confidence along the bottom, and then find 40 for the degrees of freedom, that's going to give us our t-score. So x bar is going to be 31,782 plus or minus our t-score of 1.684 times the 1456 over square root 41, which is going to give us 31,782 plus or minus 328.9231. So after performing the addition and subtraction, we get the confidence interval 31,453.08 to 32,110.92. So remember, when you're interpreting confidence interval, we're talking about the mean salaries. We can be 90% confidence that the mean salary of a beginning zoologist is between these two values. Our last problem says, it is said the proportion of students bullied in a school year is 38%. A researcher believes this is too high and collects data on an SRS of 50 schools and find they have a proportion of 19% of students who are bullied. Is there evidence to support the researcher's claim at alpha equals 0.01? So this is an example of a hypothesis test. So first thing, we want to write our hypothesis. So our null hypothesis, remember, is always equal to our population. So my proportion population is 0.38. My alternative is based on what the claim is, and our researcher believes it's too high. So the alternative is that the proportion is less than 0.38. Our p-hat that we're looking at is 0.19. And then our standard error, we use the population proportion to calculate. So 0.38 times 1 minus 0.38 all over 50 underneath the square root, which is going to give us a standard error of 0.0686. So if we're looking at our curve, our proportion is 0.38 and our sample proportion is 0.19. And we're trying to see if we're below that. So I need to calculate the p-value, but first to do that I need to calculate my z-score. So we're going to do 0.19 minus 0.38 over our standard error, 0.0686, which is going to give us negative 2.77. So using our z-score chart, looking at negative 2.77, that gives the p-value of 0.0028, which is less than our alpha of 0.01. So if our p-value is less than alpha, that means we reject our null hypothesis. And then our sentence would say, there is evidence the proportion of students bullied is less than 38%. Please let me know if you have any questions over Final Exam Review 3 or if there's any questions you have over the previous final exam reviews.